of Engineering, or POE. Hopefully you are doing well. What we are looking at is what you're going to look at for the first assignment while we're out. Your assignment is going to cover both Friday and Tuesday. So this Friday the 20th, you will not have a new assignment posted until Friday the 27th. So you'll get a week to kind of complete it, since the notes for yours are a little bit longer and the problems are a little bit longer for what we are trying to do. After that, we'll probably have daily assignments, or not daily, but every Tuesday and Friday assignments to work at and look at there. So what you're going to start off looking at, kind of one of the last main topics we're going to do before we are sent out on leave, is fluid power. So fluid power is the same kind of formula based off the formula sheet. You can see I pulled up the formula sheet snip here on the right. You got absolute pressure is your force divided by your area. You got Charles' law, Gay-Lussac's, Boyle's law, flow rate. Then you've got just area, velocity, or area, and your flow velocity, and then your power. Created that along with your absolute pressure. I'll go over all those a little bit more in depth here in a second. What you're going to look at is complete the fluid power practice problems on the Learn site. So again, this video will go through. You don't need to transfer anything grade-wise into Google Classroom. I'll collect all the grades through the learn.mywccc site. And again, when you're logging into that website, you're signing in just like you did at computers at school. So if we take a look onto the classroom page here, your fluid power is here, everything's set up. First, watch this video. It does a little better job of explaining things than I would do. If we were in class, I would show this video, and then what I would do is what I'm going to do now is jump and look at the Project Lead the Ways notes, kind of just tie up some loose ends to help you answer those questions. Also, while we're here, formula sheet, if and when you need it, it's right there. It's reference to those fluid mechanics that I'm looking at there. So you'll be looking here. So what we're going to do is look at those notes. So if I find them here, make that a little bit larger and we'll start talking. So gases, again, 3 different variables: temperature, pressure, and volume. So gas doesn't have divine volume. You can compress them, and they are lighter than the liquids for us. So absolute pressure. So when you're reading through the questions, you're looking at some stuff there. It's used to complete our calculations. Atmospheric pressure is known as barometric pressure. This is the weight of the air molecules. The application of air pressure is when your ears pop, going up high buildings or driving up a mountain or a roller coaster. The pressure is balancing out the inside and outside of that ear. So to get the absolute pressure, what we're going to do is we're going to take gauge pressure plus atmospheric pressure to get that absolute pressure. So pressure is measured in pounds per square inch, or PSI. Standard atmospheric pressure we're going to use for all these problems today is 14.7. So if a gauge reads 120 PSI, what's the absolute pressure? We're going to take the 120 PSI plus the 14.7 PSI and get 134.7 PSI. Absolute temperature, 0 degrees Fahrenheit does not represent a true 0 degrees. Absolute 0 is actually negative 460 degrees Fahrenheit. So when we're talking about absolute temperature inside of our problems today, we are going to measure those in Rankine. So to calculate Rankine, we're going to take Fahrenheit temperature plus 460 and then plug that into the formulas that need it. So if temperature is 65 degrees Fahrenheit, absolute is 65 plus the 460, which gives us 525 Rankine. So our equations that we're going to use should be using the absolute temperature for us. So pressure, the force being exerted on a fluid against a surface. The surface area we're looking at is going to be the cylinders. So the pressure is equal to force over that area. So pressure is going to be pounds per square inch. Force will be in pounds. Area will be in square inches. So Pascal's law, just like you saw in the video, just kind of a little thing there. Look in the cylinder, how much pressure can be produced with a 3-inch diameter cylinder and 60 pounds of force. Well, just like any other project lead the way question, formula, area is pi r squared. That's radius. They give us diameter. Make sure you cut that in half. So therefore, your area you're plugging in is roughly 7.07. So your pressure is force divided by area. 60 pounds of pressure. Area that we've got, that means we've got about 8.5 psi being created by each one of those different cylinders. So the different laws we're going to look at are these three. Boyle's law is looking at as the volume decreases, the pressure increases. So your example there, volume going down, pressure increasing there. So your formula being pressure at one temperature times the volume at another equals pressure times volume at a second. So the example, cylinder filled with 40 inches cubed of air pressure at 60 psi, compressed to 10 cubic inches. What's the resulting absolute pressure? There's the model of it, squeezing that down. Plug in or write down everything you know, just like the beginning of the year. Write down what you know to figure out what you don't know. Use the formula from the previous slide. Oh, sorry, we had to convert to absolute pressure, so we had to add that 14.7 onto our pressure from our gauge. Plug and chug. You end up with close to 300 psi. When you're doing questions on the Learn page, don't worry about rounding or anything else like that or using the sig figs. Just get an answer and be able to plug that in and work with it. Charles' law is the next one. As the temperature increases, volume increases. So the pressure is staying the same. You're just changing the volume that's there. Again, noting with this one, it's absolute temperature. So you got to do those conversions for us that we did in a couple slides before. So here, they give you the information, 28 cubic inches, 32 degrees Fahrenheit. We want to heat it to 200 degrees Fahrenheit with the resulting volume. So we've got to create and work through. Temperatures don't work. Calculate those absolute temperatures by adding that 460. Plug it into our formula, plug, chug, solve. Again, when you're going through, don't worry about sig figs. Go and actually use the answers when you're using it on the Learn page. You've got your final answer there. Last one, as the temperature increases, the pressure on the outside of that body containing the gas is also going to increase, but the volume is going to stay the same. Making sure you use absolute temperature and absolute pressure when you're plugging in with those. So we have 300 cubic inches of volume. That's going to stay the same. We have a temperature of 62, gauge pressure of 120. Temperature rises to 90 degrees, so we got to calculate that absolute pressure. What do we know? Convert into the things we need. We need to do absolute pressure by adding the 14.7. We need to calculate our Rankine, our absolute temperature, by adding the 460 to both. Plug into our formula, work our way through. Again, don't worry about sig figs or anything else like that. Be able to work and solve with those. So an example again, setting that up. Final pressure there. Final pressure there is not the absolute temperature like they look for. How do we get that? We've got to subtract the 14.7 to be able to then get what that gauge pressure is for our thing. So that is the different setup for what we're trying to do. Let's see if we can exit through and look at the Learn page for you. So as you go through, You're going into the Learn page. I'll pull it up and over here for you. I'll turn my mode into student mode for you so I can see the same thing you are going to see. So when you get to that class, you'll see right here the fluid power practice problems. Continue attempt. So as it's broken down, each one of the pages is connected with the same related. So the first two questions are related to each other. 3 and 4 are related to each other. It's going through. You can hit a check button to go through. So if I wanted to say that one is 52, I can hit check. It's incorrect. So you can go ahead and get 3 chances before you don't get any credit on those different ones. Same thing. You're working your way through. That guy works. One question related to itself. Sorry about the way everything is formatted there. I think you can be able to read the questions, fight your way through them. Everything's set up there. So those 3 are related. And then those 2 are related with each other. So if you got questions on it, please let me know. Again, this assignment is not due until the 27th. So you've got time to look over the notes, take some time setting up, make sure you're answering the right question with what you're trying to do there. Think about it again. It's Project Lead the Way question, so every once in a while they try to confuse you with one. Let's do what you can do. Ask me some questions if you need to. Again, office hours are 7:15 to about 10:15 every day. I'll answer some emails to work through with that. So have a great day. Enjoy. Stay away from each other.